Hello, everyone. Thanks for joining me today in my talk about how would we build the cloud infrastructure as a code with .NET Core. My name is Hossam Barakat, and I work as a technical lead with a company here at Sydney, Australia called Willow. This is my Twitter handle if you would like to follow me or reach out to me with any questions after the talk. My agenda for today is to talk about what is infrastructure as a code, how would we build the infrastructure as a code with the core of our talk today, which is Pulumi. Then we'll learn about the main concepts that everyone is using Plume has to be aware of. After that, we'll see how would we provision the resources required to create a serverless application. And then we'll touch on how would we integrate Plume with a continuous delivery pipeline. Finally, we'll wrap up with thinking about testing the infrastructure code written by Plume. So let's kick off things by talking about infrastructure as a code. Historically, we used to host our applications in physical data centers and where we had the servers, the racks, and everything in there. But with the rise of the cloud computing, most of us started moving our application from those physical data centers into the cloud, as Scott was doing, as we have seen in the keynote. But the very first question that we were facing when we started moving our applications to the cloud was, how would I provision my resources? How would I create that virtual machine as a first step? Or how would I create my web app? And the first answer to that question was just point and click. You open the Azure portal or AWS portal, you click on a button to say, I'd like to provision a virtual machine. You fill in a bunch of properties, and a few minutes later, you have a web app or a virtual machine or whatever resource you're provisioning. But after a while, we realized actually we might not should have done that, because with the provisioning of resources manually, we usually end up with what's called Snowflake servers, which is basically a servers that each one is represented with slightly different configurations. So if I have an application and that application has multiple environments, let's say I have development, staging, production, and I would like to provision my application across all of those environments. If I provision those servers manually, each one of them will have a slightly variance in there, which usually leads to troubles like something is working on my development environment but not on production, or the other way around. So that led us as a community to start moving into what's called infrastructure as a code. And when we started working with infrastructure as a code, we had the very first approach. The idea behind the infrastructure as a code is pretty simple. You just provision the resources using code. So this gives us a lot of consistency and like you can provision the same resources again and again and again. So you have this reliability with provisioning resources. You can reproduce the same outcome multiple times. And the first approach when we started working with infrastructure as a code was the imperative approach. So we were using like the Azure CLI or AWS CLI or anything like that, in addition with Bash scripts to provision the resources. So if we had a virtual machine to provision, I will just write a command to provision that virtual machine. But with a more complex application, we usually have a lot of commands to provision the resources. So I might end up with a Bash script or PowerShell script with like 40 or 50 commands. But this introduced a bit of a challenge. It have overcome a bunch of the challenges in terms of reproducing the same resources, but what if one of the commands failed? How would I handle the error of that command? Like if the command number 30 out of 50 commands Bash script failed, how would I make sure that I have proper error handling in there so I don't end up with an inconsistent environment? Also, how would I have idempotency? So after I fix the issue that I had in my application, I can rerun the whole script to recreate all of the resources that I have in my environment without having duplicate resources. So those challenges made the scripts harder to maintain, because with every command I have to have idempotency, error handling. And if we think about tearing down those resources, so if I have a development environment and I no longer want to use this environment, I basically need to write another script to tear down. So as an industry, it's common for us to abstract those kind of common problems. And that's what we have done. By abstracting all of those common issues, idempotency, error handling, provisioning, and updates to existing resources, by using an approach called declarative infrastructure as a code. And the idea behind declarative infrastructure as a code is abstracting all of those concerns, idempotency, error handling into the tool. So I end up as developer writing a script to describe the desired state. So I only describe I have a virtual machine, and that virtual machine will have inside of it, would have that amount of CPU and that amount of memory. And it's up to the tool to do all of the logic to determine what needs to happen to the cloud, what commands needs to be called to provision that virtual machine. And if we look at the current industry, we will find a lot of tools that help us achieve this declarative infrastructure as a code approach, such as Azure Resource Manager, AWS CloudFormation, Google Deployment Manager, and the most famous one is Terraform.
Margaret was the tech lead on the Apollo moon landing project. She built all the software that took Neil Armstrong, Buzz Aldrin, and the rest of the Apollo astronauts to the moon and brought them back.
Sorry? With the interruption there, I couldn't hear well. We have Terraform, and Terraform is the most famous tool right now because it supports multiple clouds and it's also open source. But the problem that I faced when I was working with this tool is basically most of those tools were written in YAML files or JSON files or something like Terraform. It's written in a specific language. So I'm coming from a development background, and I don't usually maintain those resources or those scripts on a daily basis. So I end up with a little bit of trouble when I try to maintain those resources. And the other thing that was also didn't make sense or wasn't intuitive for me is all of the changes that I wanted to introduce to the YAML file to come to constructs like for loops, if condition. Those things are not really part of the YAML origination. So we wanted to add all of those concerns into those languages. It felt like learning a totally new language. And something like YAML has a lot of sharp edges inside of it. And if you spend a lot of time, you will definitely be paired with one of those edges. And you can look into that website that's called NoYAML. It has a lot of funny things in there, thanks to Jeff Huntley, who put it together. But you will find a lot of things. So all of the sharp edges and all of the things that we want to inject to YAML to come up with all of those constructs makes it really harder to maintain over time. But the good news is, thanks to Pulumi, there is a different way that we can provision infrastructure as a code without the need to write or learn all of those YAML or JSON or domain-specific language. So I would like to show you what is Pulumi is all about. Pulumi is an open source infrastructure as a code tool that enables us to write infrastructure code in C# or TypeScript or Go, so we can provision all of the cloud resources that we need. And the benefits of that are a lot. So think about if I would like to write a for loop or an if condition, it's part of the language, nothing new to be learned in there. If I would like to, if I found a piece of functionality that's kind of a common and can be used in other teams in my company, I can start doing abstractions and share those abstractions using my favorite package management. If I'm using TypeScript or JavaScript, I can go with NPM. In .NET, I can go with NuGet packages. And if it's C# or a TypeScript, I can use my IDE that I'm used to with all of the themes, all of the shortcuts. I can do refactoring, code completion, static type checking. All of those are just built-in things. It's solved problem. We don't have to reinvent solutions for those problems. And finally, with unit testing, if I'm working on .NET, I can use something like XUnit or NUnit. The video animation destroying the audio quality, I think we don't have any more animations, so that shouldn't be an issue. So those are the kind of benefits that we have in there. So let me jump into the terminal and show you how would we actually build our very first Pulumi application. In order to use Pulumi, the very first thing we need to do is to install a CLI called Pulumi. And to create a Pulumi application, you run Pulumi U. This will show us all of the templates that I can use to provision Pulumi. Pulumi works across multiple clouds. So we can see here AWS, Azure, GCP, and even Kubernetes. Today's talk will be using Azure and C#, but as you can see, you can use the Pulumi with other clouds and even with Kubernetes. So we'll use Azure C#. Pulumi CLI will ask me a set of properties about my project that I'm trying to provision. So I'll go with Pulumi 1. Description of the project. What is the stack? Think of the stack as if it's an environment. So if you have a development, staging, pre-prod, this is a stack. So I'll keep it just development. And where will my resources be hosted? I'm living in Sydney, Australia, so I'll use Australia East. This is the closest to me. What will happen right now is Pulumi CLI will provision a .NET Core 3.1 console application. And let's jump into the Visual Studio Code to see what are the content of that application. So it's simple .NET Core 3.1, and it has a NuGet package installed inside of it, Pulumi.Azure, and this is the package that enables us to describe the desired state of our resources. We have a YAML file. I know there is an irony here that we can't get away from YAML, but the good thing is we are not injecting it with all of those if conditions, for loops, arrays, variables, and everything. The key value of this file is because Pulumi supports multiple runtimes, we need to know what kind of runtime our project is built with. The next file is a configurations of my environment, because I might need to use a different location of the resources for the development environment, because the development team in Australia, but the actual users of the applications are living in US, so I can change those configurations. Similar things can be done with the amount of CPU, the amount of memory, and any other configurable values that I want to have across my stacks. The next thing is we have a program, and it's one-liner. It's using a class from the Pulumi package. It's deployment.runStack. Inside the stack class, this is where we actually define the resources of the application. So we create a class that inherits from a stack, and it's not the stack structure, it's just a class called the stack from Pulumi. And in the constructor of this class, we go and create our resources. And we create the resources by just creating a new instance of the resource. So in Azure, if you haven't used Azure, resource group is a container for resources. So we create a resource group, and in this resource group, with this new instance, I will go and provision a storage account. So creating a storage account in Azure is just a new instance of the account class. I want to change the properties of that account. They are just set of properties that I pass to my class constructor. And the good thing, since this is a statically typed language, if I write something wrong, I will immediately get this feedback loop of with this red squiggly that I have written something wrong. I cannot compile my application. And because still we are statically typed and I'm in C#, I can easily get code completion out of the box. The last thing that I will show you here in this generated code is the idea of the output properties. Once I have a storage account, I need to have the connection string so I can give that connection string to my application so that my application can start uploading files to that storage account. And the value of the connection string will only be available after the storage account has been actually provisioned into Azure. So after I get the connection string, I need to actually write this as an output of my application so I can copy that output, pass it to my application so that it can start uploading files there. And we do this by creating this generic type called output. Output means that the value of this property will only be available after the resource has been provisioned. And we also tag it with the output attribute, which those two things will mean that the value of this property will be printed to the console after the resource has been provisioned. And we set the value of this property. It's just a normal property. We set the value of it as an outcome of the storage account property called primary connection string. So it's straightforward. However, if you have more resources, as we will see later, it becomes very handy to have those kind of properties. So let's go and provision the resources that we have in here. And we do this by using Pulumi up. Once we run Pulumi up, Pulumi will do previewing of the resources that will be provisioned if I were to go with go ahead and actually provision those resources. So right now I'm expected to see a resource group and a storage account sitting inside this resource group. It usually takes a few seconds. There we go. We have the plan of the resources that will be provisioned. If I go ahead and say yes, this will actually go and provision both resources. And the way, if you're wondering how Pulumi knows which Azure account to connect to, if you are running on your local machine and you are logged into your Azure CLI, Lumi will respect those credentials, pick them up from there, pick the default subscription that you have, and will connect to that subscription. Same thing happens with other clouds or like AWS or any other cloud that you are working with. If we are in a CI environment, usually I will not be logged into that Azure CLI, so I can pass those values or credentials to Pulumi using environment variable that it can pick it up from. So here we go. The resources has been provisioned for us, the resource group and storage account. And the output was the connection string. If I would like to change the resource or one of the resources, originally, if this was an imperative code, I have to check if the resource exists, then I'll update the value from this to that. But with Pulumi, I don't need to do anything apart from just changing the desired state. So if I want to change the storage account from standard, let's say, to premium, I just change it in here. Once I do this, and then I get back to the terminal, let's clear this up, say Pulumi up. This will show us that one resource needs to be updated and the resource group doesn't need to be updated because it's already there and I didn't do any changes to that resource group. It's still going through the previewing phase. And there we go. We only have one change happening in there. And it's a change to that storage account. So let's go ahead and proceed with updating the storage account. This will go replace the storage account and print the new connection string. And if I switch to the Azure portal, just to show you that the resources has been provisioned, this is going through the provisioning phase. Let's bring the Azure portal there. This is a simple account there. If I refresh, I can see that the resource group has been provisioned for me. The thing to notice here is there is this unique string at the end of the resource group. This is part of the Pulumi features because if you would like to create multiple environments and you don't want to have collision between the resources, Pulumi automatically adds this unique string at the end of the resource name. We have control to not do this if we don't like to, as I will show you in the next step. Right now, I'm expecting the resources to be created. So if I jump again to the resource group, I will see both resources has been provisioned. One of them two storage accounts, and now both one deleted and it's only one has been created. And this is the premium account that I just updated. If we ended up with a case that I no longer need those resources, I would like to just destroy them or tear them down, I just use Pulumi destroy. Ask Pulumi to destroy those resources, ask for a confirmation, go ahead, and bam, we are done with tearing down all of the resources that has been provisioned. So let's get back to the slides and go through a comparison between Terraform and Plume. And the value of this comparison is to see how much you would need to learn if you were to go with Terraform versus Pulumi. So on the left-hand side is a Terraform script. So if I would like to provision or create a resource group, I need to learn the syntax of creating any resource inside Terraform with this resource name, resource type, resource name, where is the location. However, in C# or TypeScript or Go, it's just a new instance. If I want to define a variable of the type array, I need to learn this syntax of the variables and this specific type that called list. However, in C#, it's just an array. Nothing to learn there. If I want to loop over this array to provision a storage account per each item, I need to learn how to use this count thing. I need to learn how to read from a variable, and it's how to use a resource group, like how to access another resource. But in C#, it's just a new instance with a string interpolation. No magic in there. So as you can see, if you are coming from a development background, the learning curve is much less compared to Terraform, or even worse if you were to go with YAML or like JSON or anything like that. We'll quickly go through the key fundamentals that you have to be aware of when you are working with Pulumi. As we have seen, one of the core things in Pulumi is a project. A project is basically any directory that has the pulumi.yaml file. Usually create a project using the Pulumi new command. The next thing is the stacks. My application could have multiple stacks like development, UAT, and production. So if I would like to have different configurations across different stacks, I can do this by using Pulumi stack init. This will create the stack. And then I can set the different configurations of each environment by using Pulumi config set, where I give it the key and then I give it the value. So once I call Pulumi config set, what will happen is it will automatically update the environment stack YAML file, and this will set the key of that I have provided with its value. And I can access the value of this stack by using pulumi.config and config.require. Just creating a new instance and reading the values from that YAML file. However, as you can see, database password is something sensitive, so I might want to save this in a more secure way. And in order to save secrets inside the YAML file, usually you do this by passing the flag secret when I'm setting the config. And this will save an encrypted value or encoded value based on your environment configurations. If you are saving those YAML files locally, the default will be just encoding them. However, there are options to encrypt those values. Also, if you don't want to access or save those values inside the YAML file and access them directly, maybe on a continuous delivery pipeline, you can also do this inside the pipeline. The next thing that I want to touch on is working with C# or TypeScript or Go. You could give us the feeling that Pulumi is actually more of an imperative rather than declarative. However, actually, Pulumi is still declarative. Even though we are creating a new instances, Pulumi is still declarative. And I would like to show you this by looking under the hood of how Pulumi actually works. When we have a new resource that is written in our code, we pass this resource to the Pulumi CLI. And the very first thing that Pulumi CLI do is look up the value inside the state. So the value inside the state is the current set of resources. It's a snapshot of the resources that has been provisioned. And at the very beginning, this file will be empty, nothing inside the state. So you can see here, the code represents the desired state, the state represents the current. And the very first step when we go with Pulumi CLI, when we say up, it goes through the planning phase. And the outcome of the planning phase is basically a dependency graph of the resources that needs to be provisioned. And it's a dependency graph because we want to know the sequence where we will provision the resources. So as we have seen in the last demo, I had a resource group that will include a storage account. So it makes sense to provision the resource group first and then provision the storage account. Also, the dependency graph helps Pulumi to determine some sort of parallelism, if possible, while it's provisioning the resources. The next phase is taking this dependency graph, passing it into the next phase, which is apply. And apply, we will basically take the outcome of that planning phase and start calling the actual cloud providers like AWS or Azure to create, update, or delete the resources. After the resources are created, we get back and update our state. So the next time we get back to or update our desired state, the Pulumi CLI can determine the delta between the desired and the current state. So this approach means that Pulumi is still a declarative approach and it's not comparative. And if you compare this approach with something like Terraform, you will find it's working pretty much the same way. So the approach is pretty much the same. So this is giving us the kind of the best of both worlds, having a declarative approach, but still I'm using all of the benefits of statically typed language with the refactoring, IntelliSense, and everything. So let's switch gears and go and see how would we actually provision a little bit more complicated application. So I wanted to create a small application, and that application has 3 resources. I have a web app. It's a single page application that I would like to host inside a storage account. And then that web application will be calling a set of APIs that are implemented using Azure Functions. If Azure Function is a serverless function, and that serverless function is similar to AWS Lambda. That function will be saving its data into a serverless database called Cosmos DB. So this is pretty much what I wanted to provision. So it doesn't sound complicated, but as we will see, the number of resources required to provision this application is a lot. The first one is a storage account. We have seen this last time, pretty easy, straightforward, and done. But then I started looking into how would I provision Cosmos DB? I found that to provision the Cosmos DB, I need to provision 3 resources: Cosmos account, SQL database, and a container. Container, think of it like a table. It's not really a table, but think of it this way just to make it easy. The next thing is provisioning the Azure Function app. And this is where things became very, very interesting to me, because I found that I have to provision the function app. I need to provision an app service plan. And that app service plan will have something called function app. And the function app requires storage account to save some information about that function app. And the function app also needs to know where is the code that it will execute. And that code that will be executed is going to be hosted as a plop inside a container inside the storage account. So as you can see, the number of resources started to get bigger and bigger, and the dependencies started to get more complicated. So let's see how would Pulumi help us provision all of those resources while we are maintaining the application and making it sure that it's easily maintainable application. So let me switch to the application here. All right, cool. So this is our application. The very first thing that we wanted to provision is the storage account, the static website. So we have seen this in the last demo. I create a storage account, and I just passed a few other properties. Remember that unique string that we had at the end of the resource group? I can change this globally, or can I change it by resource? So in this case, if I want to set a specific name, I can just pass the property name to my account argument. And the same thing for the storage group. If I pass the exact name, in this case, expand this, I can see that I can set, I have a prefix for my application, and then I have the stack name. So my application is team time zone dash dev, or team time zone dash UAT, and so on. However, after I created the storage accounts in Azure enables us to host static websites. However, we can't really set a property that's called like static website equal true. There is no such thing. it's not available for us yet. It's not available in Azure ARM. It's not a Pulumi limitation, it's just an Azure limitation. So if I was working in any other environment that's not Lumi, I had to implement my infrastructure code with some imperative or a script to actually go and call Azure API to set this property. However, since I'm inside C#, I can add the NuGet package of the Azure storage and make a call to that API to set this property. And that's what we are doing in here. I have this method that's called enable a static website. In here, I'm just using the Azure NuGet package to set that property of a static website to true. And I have a bit of logic in here to make sure that I don't execute this code during the preview phase, because my function requires the connection string, which will only be available after the resource has been already provisioned. Once I have this method, I thought, how would I call it? Because the connection string is not available to me yet. Lumi offers this method that's called apply, which you can call in any output variable. And Pulumi will trigger the lambda method, which is the parameter of this apply, with the actual value of the output variable. So after the resource has been provisioned, the apply call will trigger my enable static website with the value of the connection string. So the key point here is I didn't have to change context between C# and like PowerShell or like ARM template and PowerShell or ARM template and something else. I don't need to switch context. It's just one application, one infrastructure as a code approach. So there is no context switching over here. So after I provisioned the static website, I went ahead with provisioning the Cosmos DB. And it was, to be honest, was pretty straightforward. There are just 3 resources, Cosmos DB account, database that is using that Cosmos DB account, Cosmos account. And then we have a container which is hosted inside the database. I know we are using a lot of regions in here, and the reason behind that is the code has started to get a little bit bigger. And I don't use regions in my production code. I'm using it here for the demo to make it easy for you to follow. So if it hit a nerve or something, or it hurts your eyes, bear with me, we will get rid of them shortly. So in order to start getting things back on track in terms of the lines of code and the maintainability, I thought, all right, how about I start by refactoring this code to a method? So how would I extract those 3 resources into a method? And this is what I have done. I've created the method that only have those 3 resources. So there you go, the regions are gone, and I only have the resources in here. And then I started looking into, all right, this started to get better. How would I provision? So my code is just much shorter now, just one liner to provision the Cosmos DB. How would I provision the Azure function? To provision the Azure function, I actually have to provision 5 resources with a lot of dependencies between them. So those dependencies means I have a storage account, app service plan, and all of them just accepting a few parameters here and there. You just need to know what you need to provide them. And this is just normal properties. However, after I just configured all of those resources, I found again I cut out of maintainability zone, and it's 141 lines of code. So this is getting a lot bigger. And thinking about this Azure function and the static website, I thought actually it might make sense for other teams in my company that they would be interested in reusing this Azure function. And now every team has to go and configure all of those resources. And same idea with the static website. If might be other people would like to host single page application inside the storage account. And if they were to, they have to overcome the same issue with enable static website. So the good thing is Lumi itself enables us to introduce abstractions into the application. So I started introducing a static website abstraction, and that static website abstraction is basically by inheriting from a class called the component resource. And once we do this, we introduced a new logical resource. This is nothing that would be provisioned. It's just a container for a set of resources. And I can provide parameters to my class constructor. And I have to call a base constructor, which is giving like the logical name of my resource and passing what is the name of the resource and the resource. And all what I have in the static website is the storage account and the method of enabling a static website, which I have shown to you previously. The good thing with this abstraction is if any of my team members would like to host any single page application, they would just use this new resource that's called the static website. And once Microsoft provide us with this property, I just need to fix the property in this abstraction, and the consumers don't need to worry about it. The code for maintainability is still the same. And the same thing with the Azure function. I have created a new logical resource, which is called archive function app, by inheriting from the component resource, copying all of the 5 resources that are required to provision my Azure function inside of this class. So you have the storage account, the app service plan, and the rest of the resources. I have also provided sorry for the scrolling here. I have provided a lot of parameters to my Azure function app, like the app settings, where is my source code, what is the prefix, what is the resource group name. And I can add any parameters that makes more sense. So once I started introducing those kind of abstractions, my final version of the code became much more readable, and I didn't have to have any regions or anything like that. So this is the final version right now. I have a static website. That's a resource, no magic in there. I have a Cosmos DB. I didn't create an abstraction over the Cosmos DB because it didn't resonate well for this particular application. And this is something that we usually need to think about when we are abstracting resources, because you don't want to kind of have a lot of abstractions that are unnecessary. For the static website and the Azure function app, they made sense to me. However, Cosmos DB didn't make sense. And you need to think about those abstractions in your particular situation. And finally, we have the Azure function, which became much more smaller because I just need to provide the specific parameters that are relevant to that function app. And once I saw this piece of code looking like that, it made it to me as if I'm presenting my architecture. This is how I thought about my application when I started it. When I started designing this application, I wanted to have an application that has 3 resources. Static website that talks to a function app which saves data into Cosmos DB. So as you can see, those kind of abstractions helps us in terms of having an intent revealing code. And the abstractions as well, with complex abstractions like function app, helps us to bring more practices, a good practice from networking and security into them. So as developers, we don't need to worry about all of those kind of concerns when we are consuming them. If I want to have an Azure function app, I just one new instance of a class and I'm done. I didn't need to think a lot about those aspects because they already implemented in the abstraction. So far, I'll not actually go and provision those resources, because if I did that, it will take like 15 minutes because of a lot of resources has to be provisioned. But once I provision those resources, one of the things, if you are using the Pulumi SaaS offering, you will get a nice presentation of the provisioned resources. So Pulumi has this offering like similar to the Terraform Enterprise, where you can manage all of the state of your resources, and you can see the stack and the provisioned resources. And as we can see here, it's showing me a graph of the dependencies that I have provisioned. And with those abstractions, even Plume were able to show me a group of those resources abstracted in this new kind of resource. So this is my Azure function. This is my static website. Cosmos DB, it wasn't abstracted, so it's showing it just immediately under my stack. So those kind of abstractions also becomes handy in terms of understanding how the application has been built and how to like get your head around it, basically. So far, I've been showing you how would we provision the resources from my CLI. But most of us wouldn't provision the resources by using CLI. We would be using a deployment pipeline. And Pulumi makes it pretty easy to be integrated with any pipeline. I have to have my code, and then I have the preview phase. In the preview phase, I would select the stack that I'm going to provision, and then I run Pulumi preview. Obviously, I need to provide the credentials via environment variables, and then usually I have a manual step where I just review what kind of resources will be created, updated, or deleted in my environment. And this is usually like an approval step. Once I approve, the Pulumi app will actually go and provision the resources that I have asked it, or basically was the outcome of the preview phase. The key thing that you need to think about when you are integrating Pulumi with the deployment pipeline is, where would you save your state file? Pulumi supports saving the state file in multiple locations, like using their online offering, or you can save it in something like Azure Storage Account or AWS S3. Whatever you choose, you need to make sure that this file is saved in a secure way, because it will have sensitive information inside of it, such as the connection string that we have seen with the storage account. So it's pretty important to make sure that you have the state file saved in a secure place. The next thing that I will talk about is the testing. So after we have infrastructure code written, I would like to verify that my code is actually working as expected, similar to any other code. And we usually do this with unit testing and integration testing. Unit testing in the context of infrastructure as a code is you can apply policies like, I would like to make sure that if I have a virtual machine, that it doesn't open a port for remote desktop, as an example, or all of the resource groups has a product name as a tag. So I can run those tests without even provisioning the resources, because it's a statically typed language. I can access all of those properties while I'm running the code locally. The next aspect is the integration testing. With the integration testing, I would like to make sure that if I run this application, it will actually provision the resources. The provisioning part is actually working. And after I provision, I might need to inspect some of the properties of the provisioned resources. So this is where the integration testing will come in handy. Right now, with Pulumi, I can write unit tests for my infrastructure as a code in C#, as I will show you in a second. However, I can't do this right now for the integration testing. Integration testing, there is a framework for Pulumi, but it's in Go right now. However, for unit testing, we can write it in C#. So I'll show you here an example of how would I make sure that all of the resource groups in my application has a product name as a tag. The first thing we do is we run a method here. It's called test async. This is just a utility method that will go and run all of the resources in memory, like deployment run async, and it will return me all of the resources. And out of those resources, I will grab the resource groups. And those resource groups, I will verify that all of them has a tag that's called product name. So this, I can start applying more policies like accessing, as we said, the port, or having SSH access or anything like that. I can start applying all sorts of things with the unit tests. The key thing to keep in mind that if you are working with output variables, the values of those variables will not be available for you during the unit testing, because it's only available after the resource has been provisioned. So you can't really verify that the connection string property has value. It doesn't exist yet. And this is how you do the unit testing. So let's summarize what we have covered so far. Lumi is an infrastructure as a code tool that supports multiple cloud, and it's an open source tool. Pulumi supports multiple languages, C#, Go, and Node.js. It's still a declarative language. It's not imperative, although we are using new instances. As we have seen, the way Pulumi works makes it still declarative language. Pulumi has a few key concepts that you need to be aware of. Project, which is any directory that has the Pulumi.yaml file, the stack, which is a similar independently configurable instance where we have like different configurations can be applied. I apply those configurations via YAML files, and I can read them from the C# code. Lumi itself enables us to have abstractions, as we have seen with the Azure function and with the static website. Those abstractions makes it easy to share code with other teams inside the organization. So I can package my class into a NuGet package and share it with other teams so they can create Azure functions. Also, Pulumi makes it easy to integrate with continuous delivery pipelines. Even better, Pulumi itself has out-of-the-box tasks that integrates with common platforms like Azure DevOps or Octopus Deploy or Jenkins and other environments as well. And finally, the testing part. Pulumi enables us to write unit testing and integration tests for our infrastructure as a code. Unit tests, we can write it in C#, integration testing, not yet. And I believe once you start working with Pulumi, you will feel that this is how the way you should write infrastructure as a code. Because if you are, especially if you are coming from a development background, I would expect that you wouldn't have a lot of learnings to do because there are a few concepts to cover in there, and then you are good to go create resources, abstractions, and everything. If you'd like to learn more about Pulumi, all of the demos that we have done today are available on my GitHub repo. I will circle the resources in the Slack channel. You can dig more about Pulumi by looking into the documentation, which is fairly up to date. And finally, there is a big gem, which is the Lumi examples repository. It has heaps and heaps of examples, and it's not like trivial examples. It has also a bit of complicated examples with different languages, with different cloud environments and everything. Finally, the slides are available by this link, and I will also share the slides over the Slack channel after that. Right now, I'll just hand over to you if you have any questions here in the chat, and I will also try to bring up the YouTube channel to see if there is any questions over there. Okay. Let's see any questions. In the chat, I'm just checking the YouTube quickly. All right, cool. Doesn't look like there is questions there. Feel free to ask any questions over the Slack channel, and I'll answer them as fast as I can. Thank you. That would be it.